All right, so these are the last two problems, 7 and 8, target round, chapter 2017, math counts. Here we go. Or no one really wants to see a picture of me, so here we go. All right, so, oh my God, that is a lot of reading. And, I do maths to try to avoid reading sometimes. I hate to admit that, but it's true. But here we go. 3/5 of the way up a hill. Okay, so we have a hill. I'm just going to draw a hill. 3/5 of the way, so I need to break this into fifths. And so 3/5 of, so 1, 2, 3, 4, 5. So 3/5 of the way up the hill is going to be right here. All right, 3/5 of the way. Jack and Jill forgot their bucket. Jill continued up the hill, and Jack went down the hill. And it took them exactly 2 minutes. 2 minutes to reach the top and reach the bottom, and reach the top and bottom, Jack and Jill, simultaneously. So, if the total distance from the bottom of the hill to the top of the hill is 1,260 feet, what is the absolute difference, so it has to be positive, between Jill's speed and Jack's speed in feet per second? And they give us minutes, right? So we have to convert this into seconds, so that's 120 seconds. And I know that rate times time is equal to distance. So, all right, and so we need to figure out the distance that Jack and Jill both walked, right? So 2/5 or 40% of 120 or 1,260 is a lot of a calculator, right? So let's go with 1,260. First I put my calculator times 0.4. All right, so we know that Jill walked 504 feet. So her rate times 120 seconds is equal to 504. Well, okay, so let's go find her feet per second rate. So I'm going to divide this by 120. And so she was going at a rate of 4.2 feet per second. Well, let's take a look at what Jack did. Well, so 1,260 feet times 0.6. All right, so I know that Jack went rate times time equals distance. So Jack went 756. His rate, I don't know that his rate, but I know his time is 120 seconds. So let's divide this. Have a great weekend.
You too. Bye.
And so I get his rate is 6.3, and the difference between 6.3 and 4.2 is 2.1. All right. Ooh, probability. We love probability. All right. 25 chips, each marked with a different integer, 1 through 25. Okay, so we have the numbers 1 through 25 are in a jar. A student draws a chip from the jar and tells everyone what the number is. The chip is then replaced. And then we have 9 more for a total of 10 students doing the exact same thing. What are the odds that at least 2 of the 10 students draw the same chip? Probably pretty high since, you don't probably mix it around. But, this is going to be a tough one because do I really have to keep track of all the possibilities? No, I don't have to keep track of all the possibilities. All I really need to know is what are the odds that they don't have any repeats, and I just subtract that from 1, and that'll give me the odds of having a repeat. So this problem is going to be solved by finding the opposite or the inverse of what we're looking for. Hold on a second. All right, so, okay, so the odds of someone picking one that no one else has picked on the first try is 25 out of 25, because no one else has gone. That's just 1. I'm not going to worry about this because 1 isn't going to change anything. So what are the odds that the second student does not pick the same thing? Well, there are 24 chips that have not been picked out of 25. How about, I'm going to have to keep track. So that's the second student. So then third student is going to be 23 chips out of 25 that they can pick. That would be new. And I'm going to continue that all the way to, well, there are 9 students, so that's going to be 16 out of 25. So the odds that something is not going to be repeated is going to be 24 times 23 times 22 times 21 times 20 times 19 times 18 times 17 times 16 all over 25 to the 9th, because we have 9 numbers, right? Because the first one we canceled out to 1 right over here. And that's going to be this heinous multiplication problem. So, okay, well, here we go. 24 times 23 times 22 times 21 times 20 times 19 times 18 times 17 times 16. All right. Who doesn't love that number? All right. So we have 4, 7, 4, 4, 6, 7, 0, 5, 2, 0, 0, 0. All right, and that's all going to be over 25 to the 9th. Now, if I had a nice graphing calculator, I could just divide it by 25 to the 5th. So I don't have a nice calculator, so I have to divide it by 9/25. So divide that by 25, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So, the odds that I do not get any repeats, 0.124379, and the odds, and so then I need to subtract that from 1, so I'm going to turn that negative, because this is the odds of it not happening, so I need to subtract out the total possibilities of pulling stuff out, and that's 1. So I'm going to add 1. And that's, oh, geez, that's not helpful. Alright, so let's try that again. So we have, so 1 minus 0.17. And so, and it's rounded to the nearest hundredth. Write your answer at. There's a probability of at least 2 of the students. Alright, and so we are going to have to round that to 88%, which is also equal to 0.88, and we want to answer as a decimal. So that is 0.88. Alright, there we go. That is the entire target round for your reviewing pleasure.